Okay, guys, we're officially online. So, guys, I didn't tell you this, but I record my math lectures, Noah and Zoe. I record my math lectures. You've seen me already? Oh, you have? I'm there.
You're famous.
I'm there. I'm famous. So, I make a lot of mistakes too. So it's really awesome. Everybody. Oh, really? Does she really?
Well, last year she did.
Oh, last year she did. Yeah. But last year I didn't do it. I think this is my first year of actually doing doing my videos. She was watching other, like Edward Berger and other awesome people. But
that sounds like it was last week.
But anyways, so what we're going to talk about today is least common multiples. All right. So most of you, I mean, probably, I would imagine all of you, Noah and Zoe too, have spent a lot of time, have done these in the past. They're really useful. Does anybody know where you've used these before? Where you use them all the time? Least common multiple. When I give you something like this, what would you need to do that?
The common denominator.
A common denominator. What do they usually call it? They call it the lowest common denominator. That is the least common multiple. That is the least common multiple. To find the lowest common denominator, the lowest common denominator is the same thing as least common multiple. So it's very useful to know how to do this, but even for more reasons than that, you'll see. I mean, as we move forward, you'll see. But so we have to talk about how to find the least common multiple, and also what it is. What it is. Remember, a lot of times people get confused when we talked about greatest common factors versus least common multiples. Their head starts to swim, right? Like, oh my God, greatest common factor, least common multiple, which one is which, right? Right? I used to have trouble with that. I still do, actually. You know, I don't know. Does anybody still have trouble with that? No? Other than me? I'm the only one, and okay, great. Thank you for giving me at least a little comfort, a little support. Right? All right, so let's talk about it. If I said between, hang on, let me see, I'll just use one of these. All right, if I was going to choose between 4, 5, and 8, and I wanted to find the the least common multiple, right? Yes, some of you already know. Some of you know exactly what you're doing. So, but what I'm going to say is this is what it is. It's 4 plus. What we're going to do is we are going to
not really a plus. He's like 4 plus.
Okay. So, all right. Okay. So we're gonna think. Okay, 1 4 is 4, right?
Yeah.
2 4s. That would be a multiple of 4s, right? In other words, multiply, right? Like 1 times 4 is 4. 2 times 4 multiply would be 8. 3 times 4 would be 12, right? Things like that. So think about it. If we had 4 plus 4 plus 4 plus 4 plus 4, those are all multiples, right? Right? That's a multiple of 2 4s. That's a multiple of 3 4s. Multiple of 4 4s. Multiple of 5 4s. So we want to know what it's going to actually, how many 4s would you need to equal a number of 5s added together and a number of 8s added together. So that is not the easiest way to do it, though. The easiest way to do it is to, well, actually, Noah, you had your hand up. What would you do?
So to find the least common multiple of 4, 5, 8,
Yeah.
we have, I learned a little bit of this.
That's fine. Yeah, with math, sure.
So, I think what you're supposed to do is that you're supposed to find what 4, 5, 8 can all fit into and the same answer.
Yes. Yes.
So, I think the answer would be 40.
Correct, but how? How did you get it?
Oh, because, well, if you think about it, times 4 would be 40. Well, it's not 8 times 4. Well, 4 and 8 are both even numbers, right? And 5 is an odd number.
Yeah.
So it needs to be something that this 5 can also be an even number at some point, and also 4 and 8.
Right, because 5 plus 5 would be 10. Then suddenly a multiple of 5 would be an even number, right? Yeah.
So since 4 times 5 is 20, but 8 can't fit into that, you have to go even higher. So that would be 40.
Okay. Yeah. Okay. So this. Yeah. Exactly. But now I'm going to show you a method that always works. Okay. You use your tree factoring. You factor it out to its prime numbers, right? Is that what you're going to say, Kareem?
Yeah.
Basically that? Okay. So we're going to do that. So we're going to use our tree factoring. We've got 2 times 2, right? Are those both prime numbers?
Yeah.
Yeah. So we can't go any further. So I'm going to circle my prime numbers.
5 is already prime.
All right. So that's just going to be 5. So I'm going to circle that one. Now this one is 2 times 4, and 4 is 2 times 2, right? So that's my prime, that's my prime, that's my prime. All right, so to find my least common multiple, Noah, what would you do?
Well, you'd have to multiply 2 times 2 times 5 times 2 times 2. Oh, no. Wait, no. Wait. Oh, yeah.
Okay, well, let me finish. Let me just finish. So you're going to look at each of these. We have, this one is 2 times 2. This one is 5. And this one is 2 times 2 times 2, right? So to find your least common multiple, you're going to take the largest number of each the largest quantities of each number from each of these, right? So there's only 2 2's here, there's 3 2's here, so my least common multiple has to at least have 3 2's, okay? So I'm going to write this, 2 times 2 times 2. That takes care of my 2's, because that doesn't have a 2, but this has 3 2's. This has 2 2's. I need the larger number of 2's, right? All right, now this one has a 5. These don't have 5's, but there is a 5, so I know my answer has to have a 5 in it. Yes? Right? And I've already taken care of the 2's from here. So that should give me my least common multiple. What is 2 times 2?
4.
What's 4 times 2?
8.
What's 8 times 5? 40. So my least common multiple is 40. Least common multiple is 40. I had to take the largest number of 2's in any given one number. And that was 3 2's. So 2 2 2. And then largest number of 5's. There's only one of them that has a 5, so I put that 5 there. And that one has 2's, but we already took care of the 2's over here. So 2 times 2 times 2 times 5 equals 40. That's your least common multiple. Okay? Now, let's try a couple more. Let's just try, yes, question.
What if you have like a massive number like 1,578,000 and then like 879 million?
Divided by 2.
No, and then
like, divided by 2. And then divided by 2.
I know, but like is there a faster way? Because it would take like a really long time to do that.
There is another way. Do I teach that? Well, okay, hang on a sec. Let me just do a few more like this first, okay? And then maybe I'll do that. There is another way. And I've actually mentioned it to you guys in the past. But let's say I did 18, 81, and 500. 18, 81, and 500. Again, now we got bigger numbers, right? This is a little harder. I'm thinking, oh my gosh, how am I going to find my least common multiple in these? Well, I do the same thing. I bring it down to my, prime numbers, and we'll see what we got. So 18 would be 2 times 9, right? And 9 is 3 times 3. Am I right? Did I do this right? And then this one, 9 times 9, right? Which is 3 times 3. Oh, this one, bummer. Look at this. Jeepers. Okay, so 5 times 100, right? And then 10 times 10. And then 2 times 5. And I'm going to do 5 times 2 here so I can see my 5's together. Okay. right? Did I do them all right?
Yeah.
Okay, so now to find my least common multiple would equal, now I gotta see, I have 2's. Let's start with our 2's. There's 1 2 in this one. There's no 2's in this one. Ah, there's 2 2's in this one. So what do I have here?
2 times 2.
2 times 2. I've got to use the one that has the largest number of 2's. Okay, now let's do 3's. This one has 2 3's in it. This one has 4 3's. This one has no 3's. So what do I put here? 4 3's. So 3 times 3 times 3 times 3, right? And then now 5's. I think that's the only other number, right? 2 3 2 2 5 5. Okay, so 5. So this one has no 5's. This one has no 5's. How many 5's does this one have? 3. So I got to do that. 5 times 5 times 5.
Could we use a question here?
Yeah.
Could we use the birthday cake method for this?
That is very, yes, we can. Yeah, we can. It's just I'll show you. I'll show you in just a second, okay? But you're right. Good job. I'm impressed that you thought of that. So now we got to figure it out. What's 3 times 3 times 3 times 3? 81, right? That's 9 times 9, which is 81. So that's going to be 81 times 4 times, what's that? 5 times 5 is 25 times 5 is 125. Okay, who has the calculator?
I figured it out.
Oh, you did? Okay, what is it?
4,500.
Okay, so the least common, assuming he is right, we've got 4,500. I'm going to assume he's right. 80, let's see.
I put them all in.
Yeah, that sounds about right. That sounds about right.
Wow,
Yeah.
that's the least.
That's the least common multiple, right? So remember what that means. That means 18 times something is going to equal that. 81 times something is going to equal that, and 500 times something is going to equal that. So if I gave you if I gave you something like this, 11 18ths plus 10 81s plus 7 500ths.
That kind of makes sense because
You would have to use this as your common denominator. That would be your common denominator.
that kind of makes sense because it's like they're all multiples of 9, and then 9 times 500 is 4,500.
Oh yeah, you're right. Exactly. You're right. It does make sense. Very good.
Good job, Sal.
Excellent. Good job, Sal. All right. So now, does that make sense? Are you guys getting a fist to 5? Fist to 5. Just so you know. Everybody knows this, right? Okay. So I'm going to show you. Now let's talk the birthday cake method for just a second. Then we're going to talk about it with variables. Okay. All right. So let's go.
Your answer to that one, I keep checking on my calculator and that's not it.
Really?
I keep getting 20,500.
Yeah,
Which is only good.
Oh, wait, yeah, it was 4,055. Oh, here, let me check.
Wait,
Oh, you did that. You did it. You said.
And I got 40,500.
Yeah, it's 45. Oh, it's 40.
Oops. So on that last one, the least common multiple, you got 40,500. Sorry.
Bigger than.
Yeah, I guess that makes more sense.
That's like,
Hey, guys.
Yeah.
It's
that's
40,000.
not the least. That's like the most.
Right now, okay. So now, if I gave you, let's see. Let's just find 2 more numbers. We need 2 more numbers that I. Well, I don't know. I'll just make them up. All right. So let's say we have. Let's say we have 24 and 64. And I've got 2 numbers here, right? So I'm going to show you the upside down birthday cake method. The problem is you can only use this for two numbers. You can't use it for 3 numbers. There is a way to use it for 3 numbers, but you got to use it. You got to do it in groups of 2. So I want to find the least common multiple, right? Least common multiple. I am going to use my upside down birthday cake method to find the greatest common factor. Remember how I did that? Remember? So what goes into both of these? 2. 4. I don't care. What? 2. We'll do 2. I don't care. So 2 goes in 24 how many times? 12 times. 2 goes in 64 how many times?
32.
32 times, right? All right, so now let's see. But there's 2 can go into these 2. 2 can go in this how many times? 6 times. 2 goes into this? 16 times. But look, 2 goes into those 2. This is exciting. Okay, so 2 goes into this. So 2 goes into 6 how many times? 3. 2 goes into 16 how many times? 8. Oh, there's nothing else, right? There's 1. 1. Oh, 1! We could do 1. 1 goes into that 3 times. 1 goes into that 8 times. And 1 goes into this. Oh my God! We could do this all day.
It's like a wedding.
This is fun, isn't it? Right?
Wedding cake.
It's really more like the wedding cake, right? So
It's like the sideways caterpillar.
So-
you guys, it kind of looks like one of those houses, you know, like the houses that have those things.
Shingles.
Yeah.
yeah. So when factors of 1 doesn't change anything. You see that, right? If I put a 1 here, I'd just be doing this all day if I had to, right? And all night. I don't want to. So I really don't need all this. So I'm going to just erase this.
I just wrote it down.
That's okay. You can write it down.
You're making a good choice.
But notice what I have here. I can't go any further here, so I'm going to just leave it like this. This times this is my greatest common factor, right? Those are all my factors that I factored out of these 2 numbers. So my greatest common factor is 2 times 2 times 2, which is 8, right? So my greatest common factor is equal to 8, right?
Wait, are you doing your least common factor or the greatest?
See, I'm doing my greatest common. This is greatest common factor, but now I'm going to show you where our least common multiple is. Least common multiple. What is the first letter of least?
L.
L. Watch this. I'm going to use a different color. Watch this.
Whoa.
All right. So there's your L. So your least common multiple is equal to 2 times 2 times 2 times 3. 2 times 2 times 2 times 3 times 8 times 8. All right. So that is 8 times 8 is 64 times 3. What?
192.
It's 8 times 24.
Did you do that in your head?
No. Sure.
192. Do I trust you guys? I mean,
It's 100.
this is on video, and we keep getting the wrong. Okay, good. You have a calculator. Phew. All right. So that is your least common multiple. It's this times this times this times this times this. These are your remainders. You multiply those in 2, and you got your least common multiple. Isn't that cool?
That's awesome.
Now, can I erase this? Now let's try it with 3. I'll just show you how to do it with 3. Actually, I hope I can do it with 3. I think I can. It's not like I play around with this very often. So I love experimenting when I'm doing video tapes. This is really fun. Okay, so we have. Let's try our. Well, I don't want to do a big one. Let's do a simple one. Let's do that other one. 4, 5, and 8. We know the answer to that one, right? 4, 5, and 8.
40.
All right, to use the upside down birthday cake method. Upside down
That doesn't work with these numbers here.
birthday cake method.
Does there
That
already
doesn't work because one of them is prime.
But 2 of them.
They have to all be even to be able to do the birthday cake method.
Or they'd all have to be, or like,
It could be odd.
they could be odd. They had to be composite.
Yeah.
So yeah, well, you'll see. Hang on. So in order to use the upside down birthday cake method, right? You can only use 2 at a time. Only do
Doesn't matter.
2 at a time. Now that's not true for factoring. For factoring, you can use as many as you want. But for least common multiple, it's my understanding you have to do 2 at a time. So what that means is I'm going to do these 2 first. All right.
Those 2
Oh,
first?
well, so 1, 4, and 5, right? So
Wait, but it doesn't matter which 2. Couldn't you do like 4
yeah,
and 8?
I can do any 2. I can do any 2.
Okay.
I can do any 2. I'm just doing the first 2 because they're there. So 1 goes to those, so I have the remainder. So 1 times 4 times 5 is my least common factor, my least common multiple between 4 and 5. So that the 1 times 4 times 5 is 20. That makes sense, right?
Yeah.
Right? So we're saying that 20, my least common multiple sub 1, is equal to 20. And then I've got to take my least common multiple of this and try it with the 8. So now I'm going to do 20 and 8. Aha, see? So now suddenly, and then this will give me my final least common multiple, right? So 2 goes into both of those, 10 and 4. 2 goes into both of those, 5 and 2, right? And that's as far as I can go, right? Because nothing else goes into 5 and 2 other than 1. And 1, we just found out, doesn't help me any. Makes me tired, right? Because I keep going on and on, right? So my least common multiple of these 3 now should be 2 times 2, which is 4, times 5, which is 20, times 2, which is 40. So my least common multiple is equal to 40. Isn't that cool? So that's another way to find the least common multiple. But if you have 3 numbers or 4 numbers, you have to do them in groups of 2. Right? Does that make sense? What? Does that make sense?
That's cool.
Good job, Liam, for seeing that.
Well, what about variables?
5 times 2. Or 2 times 2 times 2.
2 times 2 times 2 is 8, times 5 is 40.
What about
Right?
variables?
All right, so now variables.
Yeah.
Can I move on? You understand this, right? Yes? Okay.
Wait, but don't erase the upside down birthday cake method like on that side there.
The writing you did.
Okay.
Don't erase that because I want to do something.
All right. All right. So, okay, so now we're going to talk about least common multiples with variables. So, let me grab a number example. Find one. Where are we? Okay, so this will work. So 15 what was it? A squared b, and the other one is say 10ab cubed. 10ab cubed. So this works the same way as the other stuff, right? So this works the same way as actually we could use either method. We could use that number 1 method that I showed you, or the upside down birthday cake method, right? Let's try both. Let's do them both ways. So let's first factor out, use tree factorization, right? So what do I have? 15, what would that be?
5 times 3.
5 times 3, right? Those are both prime numbers.
Would you only
But we also have an A times an A, right? And we have a B. You agree with me? A times A and times B. So we've got all those, right? Now for this one, what do we have?
10 times, 5 times 2.
2 times 5. Those are both primes. And then we have 1A and we have 3 B's. B, 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 right? Yes? So now our least common multiple is going to be, first we'll deal with 2's. There is
Are we assuming
1, 2 here.
variables are prime numbers?
Say what?
Are we assuming variables are prime numbers?
Wise guys, do you have to be a wise guy? You're asking me a hard question on video. That's a very good question. We're just assuming we don't know what they are,
So
right?
assuming that
Because
they're prime because there's nothing else we can really do.
since we don't know what they are, we just have to use them as they are.
Oh.
You know what I mean? As unknowns. And so, so we're going to think of them as like a prime number in the tree factoring thing for now. And so, first of all, there's a 2. There's 1, 2 here. There's no 2's here, so I got to have a 2 here, right? Yes? Yeah? All right, 3's. There's a 3 here. 1, 3 here. There's no 3's here, but I have to have a 3. 3's here. Right? And then there's a 5. There's a 5 here. And there's a 5 here. So do I have 2 5's?
1 5.
No, 1 5.
Oh, why?
No, because
Because I take the largest number in 1, right? the largest number of 5s in this is only 1 5. The largest number of 5s in this is 1 5. So I'm going to put 1 5 here. And then, okay, now A's. There's 2 A's here, there's 1 A here. So, A squared.
Oh, yeah.
Right? There's 2 here, there's 1 here. I only need the one with the 2. There's 1 B here, there's 3 B's here, so B cubed, right? Piece of cake. So 2 times 3 is 6, times 5 is 30. So my least common multiple is 30 A squared B cubed.
That makes sense.
Right? Makes sense. Yeah?
Awesome. That makes total sense.
Right? Total sense. You'll find actually the variables are easier to do than the letters. I mean, than the numbers. Because think about it. All you're doing is you're taking the bigger of the 2. You know what I mean? That's A squared, that's A. So A, the bigger one, goes here. That's different from factoring. Factoring was the reverse. You were using the one with the smallest exponent. But with least common multiple, you're using the one with the biggest exponent, right? Because multiple means big. Multiply. Multiply, right? Right? It's big. Right? Factor. Factor. Right? Right? So that's that. So let's try it now with upside down birthday cake method. Can I erase this?
No.
Okay, go.
What?
All right, let's try it with upside down birthday cake.
No, Gary,
Watch this. Because I asked and you guys said you didn't say anything.
I said wait.
Who said wait?
I said Donna.
Don't ever say wait to me. Okay? Don't ever say wait. Okay, so what do we do here? We have
They both have 5 in them.
5 goes into both of them, right? So I can do 5. Let's see what I get. 5 goes into 15 how many times? 3. But I still have this stuff, so I got to keep writing that. Right? 5 goes into this 2 times, and I still have this stuff. So I have to write it. Okay, now what can I take out of 3 and 2? Nothing. Right? So how about A squared and A? What can I take out of both of those? An A. Remember, these are factors now, right here on this side. A. So I can take an A out. So what do I have here? I have 3AB, right? And here I have 2B cubed, because I took the A out, right?
I know, but why do you still have it? Because it was A squared.
Because this was A squared, which is A times A. So I took one of the A's away, but I still have one left.
Okay.
Make sense? And then here, now what can I take out of this? A B, good. And so I've got, now that'll give me 3A, and this will give me 2 what?
B squared.
B squared, because I'm taking one of them away. Okay, can I go any further?
No.
No, B cubed.
No, that's it. Okay, so now my greatest common factor, that's the nice thing about this, is it tells you 2 things. I know my greatest common factor is 5AB. And I know my least, so my greatest common factor is 5AB. And my least common multiple is 5 times A times B times 3A times 2B squared. So I'm going to do the numbers first. I'm going to do 5 times 3 times 2. And then I'm going to do A times A squared times A times B squared. So that'll give me 5 times 3 is 15 times 2 is 30. So it gives me 30
A squared B.
A squared B cubed. A squared B cubed. And I think that's what we got before, isn't it?
Yeah. Yeah.
I don't necessarily think you would use this that much for these variables. I don't think it's that helpful. I think it's more, for me, the upside down birthday cake method works better for just numbers. Because I think the variables are so easy. You know what I mean? You're just choosing, you know, you look at all of the possibilities and you choose the one that has the largest number of that variable. Right? So, but it works. It works. It all works. So that is the lecture. Is anybody, any questions at all? Before I stop? Fist of 5, least common multiple. You guys got it? Yes! Okay. We're done.